Hello everyone, my name is Masari Kawai. I have been working at Kume Sekkei as a structural engineer. Today, I'd like to explain to you the structural design of the gymnasium in Yokkaichi City, Japan. Let me begin my presentation. This shows the abstract. We designed two characteristic truss structures. Both trusses respond to the design concept. This photo is panoramic view of the building. The one in the back is the main arena, and the one in the front is a small gymnasium called Multipurpose room. This is the architectural scheme. The main feature of this project is the redevelopment of the entire park, including the landscape, and the gymnasium is the central facility. This shows the general information. 3 stories in size. The maximum span of the main arena is 76 meters. Multipurpose room has a 19-meter span. This shows the structure scheme. The orange parts are steel structures, and the gray parts are RC structures. Now, let me explain the main arena. The photo below is an interior view of the main arena. The lenticular cross-section of the Suspen-Arch structure expresses a continuous circle of motion with the soft curves. The lower corner members are shaped steel, which is intended to maintain the R shape and give a sense of presence. The shape of the arch and the suspension is perfectly symmetrical to achieve a thrust-free structure. This shows the main arena structure. The truss height at the center of the lens-shaped section is varied according to the span to equalize the stresses generated in each truss, and the members used are unified for efficient arrangement. The seismic force for the design of the main arena roof was determined using time history response analysis. This figure shows the result of the eigenvalue analysis in the horizontal direction. The first order natural period is 0.762 seconds. The figure above shows the results of the eigenvalue analysis in the vertical direction. The central table shows the results of the time response analysis. Based on these results, we set the seismic forces shown in the bottom row. Next, I will explain the structure of the multipurpose room. The photo below is a bronze frame, deep eaves, a multipurpose room, and a sports forum connected to the arena with the light from high-side light. As a space covering these areas, the designer had an image of working through the trees in the forest, with the image of recreating the scenery of a lush green park covered with trees. Before the redevelopment, we proposed an appropriate structure which we named balance frame. This figure shows the configuration of a balance frame. The subframes are supported from the balance frame at 3 locations at both end columns and the center of the span. At the eaves, we attached H-shaped steel beams because of their light weight. In the center of the span, we attached a truss structure using a step for the high-side lights, because the walkway with a concrete slab was expected to be used for running. The orthogonal beams in the sports forum section are also trusses because of the heavy weight of the concrete slab and plantings, and the orthogonal trusses are made into three-dimensional trusses in accordance with the lattice shape of the main truss structures. This figure shows the concept of seismic force burden. In a span direction, the seismic force is borne by the S-truss plus RC hybrid shear wall located at the boundary wall of the multipurpose room. And in the digit direction, the seismic force borne by the RC shear wall on the arena side connected through the third floor slab. The truss members, which bear only the long-term load, have a uniform external size of 150 mm, creating a human-scale structure that does not feel oppressive even when viewed up close. This photo shows the interior view of the entrance hall. The structure is made up of a series of trees. This photo shows the working track on the second floor. We can see the trusses up close. Conclusion: we planned two truss structures that corresponded to the design concept. The main arena was designed with a Suspen-Arch that resembled loopholes. For the multipurpose room, a truss structure was planned to create an atmosphere like working in a forest. Thank you for your listening.